quite often in worded questions, they will talk about an angle of elevation or an angle of depression. So what is an angle of elevation? Well, look at that first diagram there. You can see from the horizontal, which would be his eye level, all right, he's looking up. So the angle from that horizontal looking up is what we consider the angle of elevation. So it makes sense that if we have eye level up here at the plane and looking down towards the man from the horizontal, that would be our angle of depression. Angle of depression is one that we get wrong quite often, and I'll explain that a little bit further on. But look at this last diagram here. You can see angle of elevation, the one looking up from the horizontal, is equal to the angle of depression, which is looking down from the horizontal. So that's why we say the angle of elevation and the angle of depression can be the same thing. Let's have a look at some examples there. So Johal is standing here, 85 metres away from a building, and he's looking up to the top of the building at an angle of elevation of 70 degrees. And we're asked to find the height of the building. So let's label that in terms of what we've got. You can see our right angle triangle there. And so we have got the adjacent, we are looking for the opposite, and we have the angle. So theta is equal to 70 degrees. Opposite is what I am looking for, and the adjacent is equal to the 85 metres. What rule are we going to use there to find that opposite side or the height of the building? SOHCAHTOA. I think tan is the best one there. Tan theta equals opposite over adjacent. Tan of 70 degrees is equal to H, if you like, which is the opposite over 85. Now our unknown is up the top, so all we have to do is bring the 85 across and multiply. So 85 times tan of 70 degrees is equal to the height of the building. When we put that into our calculator, we get H is equal to 233.54 if we round off metres. Now if you read the question, it wants it correct to the nearest metre. So to the nearest metre, it's approximately 234 metres. We need to be very careful with this one. So from the observation room at Centre Point Tower in Sydney, which has a height of 160 metres, the angle of depression of a boat moored at Circular Quay is observed to be 8 degrees. Remember, that's 8 degrees from the top of the tower or from our horizontal, which is there. Okay, that's your 8 degrees there. Question says, how far from the base of the tower is the boat? So we're looking for this bit down here. Now this is where we need to use the fact that our angle of depression is equal to our angle of elevation. So we know that this bit here, this angle here, okay, that angle there, let's do it in a different colour, is equal to this angle here. So both of them must be 8 degrees. Well, how does that help us? Let's have a look at what our triangle looks like. So we know we've got a right angle triangle. We know now that this is 8 degrees here because it's the same as our angle of depression. We know that this is 160 metres, if you like, and we know that we're looking for the distance down the bottom here between the tower and the ferry. So how do we now go about working that out? Well, it's just a normal right angle triangle, isn't it? Let's label our triangle. So we have the angle we have the side opposite the angle, so that must be our opposite. We have the side between the angle and the right angle, or at least that's what we're looking for. So theta is equal to 8 degrees. Opposite equals 160. Adjacent is what we are looking for. That is our length now. So SOHCAHTOA tan theta equals opposite over adjacent. Tan of 8 degrees is equal to 160 over x. Now our x is down the bottom, so we need to switcheroo. So x is equal to 160 over tan of 8 degrees. X is equal to 1138.46 metres. Okay, that's just by putting it into our calculator. Now we go back and read the question, and it says it wants it to the nearest metre. So x, or the distance, is approximately 1138 metres. So that's to the nearest metre. Find the angle of depression from the top of the hill to a point on the ground which is 50 metres from the middle of the hill. And we need our answer to the nearest degree. Now you can see the diagram in front of you. It's all set out for you. And it's very clear there, because we know that the angle of depression is the same as the angle of elevation. So we can actually see what our triangle should look like. We know that because we want the angle of depression, which is the same as the elevation, that's the angle that we are looking for. We know this is 50 and this is 38, and there's our right angle. So again, pretty simple now that we have all the information there. Let's label our triangle. We have the side from the given angle, which is the opposite. Between the given and the right is the adjacent, and theta is what I'm looking for. So theta is my unknown, my opposite is 38, and my adjacent is equal to 50. They all seem to be tan, don't they? So tan theta equals opposite over adjacent. Tan theta equals 38 over 50. And of course we want the theta by itself, so bring the tan across and it becomes inverse tan of 38 over 50. And when we put that into our calculator, we get 37.23 degrees. Now, again, it wanted it to the nearest degree, so that is approximately 37 degrees. In part B, the question is asking what is the angle of elevation from the point on the ground to the top of the 38 metre hill? Answer to the nearest degree. Well, there's no working out here, and we all know why, don't we? Because the angle of elevation and the angle of depression are the same thing. So because angle of elevation is equal to the angle of depression, we can say that the angle of elevation is equal to 37 degrees as well.